In this tutorial, I'm going to show you how to solve a quadratic by factoring. So let's say that you have the quadratic 4w squared plus 12w plus 5 equals 0. And the first important thing that you need to make sure of is that your equation is in fact equal to 0. So if this had been 4w squared plus 12w equals -5, you would need to move that over first. So after it's set equal to 0, you're prepared to factor the left side, in this case, of the equation. So this is a great candidate for factoring by splitting the middle. I don't see a GCF, so I can jump into 4 times 5 is 20, and I need factors of 20 that add up to 12. So if I'm listing out my factors of 20, oops, I see right there a 2 and a 10 could add up to 12. So I could split that middle term to be 4w squared plus 2w plus 10w plus 5. And then I can group. So out of this first group here, I can see that the GCF would be 2w. And if I factor 2w out, we would have 2w plus 1. Out of the second group, 10w plus 5, the GCF is 5. So if I factor out a positive 5, again, I would have 2w plus 1. And remember, that's the ultimate goal, is that these two sets of parentheses match, which means then I could factor out the quantity 2w plus 1, and therefore I would be left with 2w plus 5 as the other factor. So the reason that solving by factoring works is because we have something called the zero product property. And that's if you have two things multiplied together that equal 0, that means one of those two things has to be 0. So in order to figure out what value of w would make this equation equal 0, we are going to set each factor individually equal to 0 and solve. So 2w plus 1 might equal 0, meaning this factor is 0, so 0 times this is 0. Or maybe this quantity, 2w plus 5, equals 0. So in order to get either of those quantities to equal 0, we need to solve for w to figure out what w would have to be in that instance. So in this case, if I subtract 1 from both sides and then divide by 2, I would see that w would equal -1/2. Or over here, I would subtract both sides by 5, so 2w equals -5, so therefore w would equal -5/2. So we would have two solutions there. And if I were you, I would be plugging those back into the original equation to check to make sure that they work. But for time right now, I'm going to just let you know that they do. Let's try one more. So let's say if you have something like 2w squared minus 32 equals 0, and we want to solve this by factoring. This is also a great candidate for solving by square roots, but I do want to walk through it if you're asked to solve by factoring, how to do that. So just like always, any other factoring problem, you do want to factor out a GCF if possible. So in this case, I see that I could factor out a 2, which would leave us with w squared minus 16 as our other factor. Well, w squared minus 16 is factorable. It is a difference of two squares. So that means that we would be able to factor it into two binomials, one with a plus sign and one with a minus sign. And the way that we fill these in is by figuring out what squared gets us w squared. Well, that would be w. So that starts each binomial. And what squared gets us 16 would be 4. So we have a plus 4 and a minus 4. So again, we have something like this. You could think of it as 2 times a times b equals 0. That still means either a or b has to be 0. So we take our individual factors. We can ignore the 2 because it doesn't have a w with it. So we wouldn't be able to solve for anything there. There's no way that this is going to be 0. It's 2. So we can take our other factors, the w plus 4 and the w minus 4, and set those equal to 0 and solve. So we can see that here we would get w equals -4, and over here we would get w equals +4.